small, they take unique sets of circumstances to form, and what they are is a very intense cycle. So the winds are moving in a what direction? Counterclockwise manner. So the air is being sucked in. The rotation of the air is the vortex itself, maybe 200 miles per hour. Air coming in is not flowing in at 200 miles per hour, but the vortex, the winds are upwards of 200 miles per hour. Who's had a physics class lately? Well, I didn't see his hand waving. Yeah. Nobody with a physics class. Okay. Oh, in high school, good physics class. Okay. How many of you are figure skaters? What? How many of you watch figure skating?
Figure skating.
Okay. You've seen this figure skater that starts and begins to twirl and spin, and the velocity of the skater increases. Yes, no, never seen this? Okay, a figure skater when they do their spin move.
Yeah.
I don't have skates. I would demonstrate, but I don't have skates on. Okay, this process by which you increase your velocity. You know, a figure skater, once she starts or he starts, adds no additional energy to the system, but the speed increases. I mean, when that person goes into that motion, all the energy that was going into motion has been expended, but yet they can rotate rather rapidly. That's called conservation of angular momentum. And you never had that in physics. Never had it in physics.
What is it?
Conservation of angular momentum. Okay, any of you, let's hope this happens, any of you ever play in a playground with a merry-go-round? Okay.
Oh, yeah.
Okay, you run along the edge of the merry-go-round, you hop on, but what happens if everybody goes toward the center?
It goes faster.
The merry-go-round goes faster and all the little kids go flying up. and you always bring on 2 or 3 little kids to watch this centrifugal motion at work. But no, that's conservation of angular momentum. The more you enclose energy into a shorter circular pattern, the faster it has to go. And that's what's happening with tornadoes. You're bringing this air in to a very, very small area, and it rotates like crazy. All of you have taken at one time or another something attached to a string, and you spin it around like this around your finger. Closer it gets to your finger, the slower or the faster it goes. Faster, you bet. Conservation of angular momentum. Again, the energy's in the system. So tornadoes then function best because of this principle of physics. The energy's there, it's being confined, and to accommodate the airflow and the energy, you have to increase the velocity. The velocity is increased. Okay, a tornado will generally cause death and destruction by 3 different ways. Flying debris. Flying debris is probably the most devastating type of death and destruction that happens. Second, electrical discharge and lightning is very, very common in something like this. And third, the vortex. In other words, sucking objects up off the surface. The pressure difference is phenomenal. Buildings will literally explode because the pressure outside is less than that inside, and the buildings will explode. There have been unique events associated with tornado winds. Straw, just that nice, soft, grassy-like things you get when you harvest grain, driven through fence posts, literally driven right through a fence post. Schools, literally picked up and deposited elsewhere. 2x4s through walls and through other solid objects, through car windows, through cars. anything that's flying is a potential fatal object. But the most unique thing I've ever read about is, we've all heard of raining cats and dogs. How about raining toads and frogs? Tornado going across an area with like swamp light picks up these animals and deposits them out. I mean, dozens of toads and frogs falling about the landscape. So, I mean, and you know, people picked up, deposited great distances. Generally, if you survive the impact, you're going to be okay. It's the impact coming back down that creates most of the fatalities. So if you're slammed against a building or a rock, you probably had it. But if you come in contact with something soft, odds are you're going to be okay with a few scratches. Okay, so again, tornadoes, smallest of the cyclonic storms. Hurricanes. A hurricane is a tropical cyclone, also known as a typhoon, and also known as a willy-willy. W-I-L-L-Y, W-I-L-L-Y. Your author calls it a willy-nilly. It's not a willy-nilly, it's a willy-willy. It's Australian. So willy-willies are different than hurricanes. How? Yes, it's a rotation of the earth. Southern hemisphere, you have clockwise rotation into low. Northern hemisphere, it's counterclockwise. Okay, hurricanes, I'm going to just use the term hurricane rather than tropical cyclone. It's easier and cleaner. Hurricanes form, and this goes for all of these now, at latitudes between 5 and 25 degrees north and south latitude. 5 and 25 degrees north and south latitude. So they form, and they form over water only. Will not form over land. Because the energy that drives this system, is a warm, moist air of the ocean. That warm, moist air, as it rises, is cooling off, condensing, and energy is being released into a system. It does not form closer than 5 degrees to the equator because of
the doldrums?
Nope, not the doldrums. Lack of Coriolis. Remember I said Coriolis is almost non-existent at the equator, so you don't have enough Coriolis activity near the equator. Water temperatures where these form must be 85 degrees or above, so surface water temps must be very warm. Consequently, the hurricane season typically is beginning of August to the end of October. However, we've seen hurricanes outside of these, and this again for North America, outside of this time, but most hurricanes will be beginning of August to the end of October. And the reason for that, it takes that long in the summer to heat the water up to 85 degrees. And by the end of October, water temperatures are beginning to drop again. The hurricanes for North America, now only for North America, literally began off the coast of Western Africa. And what we see off the coast of Western Africa, this is the equator. We'll have a series of isobars that form a series of waves. Remember, the equatorial low, they are still in the low pressure area, but they're slightly higher than the equator. These waves are referred to as the easterly waves. And easterly